3 minutes ago, tracking data on 3i Atlas showed something that shouldn't be possible for an object moving this fast, this far from the Sun, a measurable shift in its path that standard orbital mechanics alone can't fully explain. So let's ask the question every tracking station is asking right now. If gravity alone can't account for this shift, what actually can? Because that's really the question this entire story hinges on. Not whether the shift is real, it is, but whether the explanation behind it is as ordinary as most scientists believe, or as extraordinary as a small vocal group of researchers have suggested. And the honest answer to that question is more interesting than either extreme makes it sound. Here's what's confirmed. 3i Atlas is only the third interstellar object ever detected passing through our solar system, discovered in July 2025, moving fast enough on its hyperbolic path that it's not bound by the Sun's gravity at all, as it came from outside our solar system, and it's leaving for good. An object moving that fast, that far out, should follow a path dictated almost entirely by gravity. Predictable, clean, calculable to the decimal point. That predictability is worth appreciating for a second, because it's actually one of the most beautiful things about orbital mechanics. Give astronomers an object's mass, its velocity, and its position relative to the Sun, and they can calculate exactly where it should be, years in advance, down to a remarkably fine level of precision. That's not guesswork. That's centuries of physics, refined and tested against millions of observed objects, distilled into equations that almost never fail. Except this time, the observed path didn't perfectly match the predicted one. Tracking data compiled by observatories monitoring the comet's post-perihelion trajectory picked up a small but measurable deviation, a nudge away from the pure gravitational prediction, the kind of shift that shouldn't exist if gravity were the only force acting on this object. That single sentence is where this entire story either becomes a fascinating footnote in cometary science or a viral mystery, depending entirely on how it gets framed. And the way it's been framed across different corners of the internet over the past several weeks has varied wildly, from careful technical explanations buried in academic papers to dramatic headlines suggesting something far stranger than physics alone. Before we get into what's actually causing that shift, and there's a reason this specific detail has become one of the most argued over points in the entire 3i Atlas story, hit subscribe and stay with me, because the explanation is stranger and far more grounded than you'd expect. Here's where the impossible framing actually comes from, and it's worth being precise about it. In pure two-body orbital mechanics, an object and the Sun, nothing else, trajectory is entirely predictable from mass and gravity. Any deviation from that clean prediction technically counts as non-gravitational acceleration, a catch-all term for forces acting on an object that aren't explained by gravity alone. On paper, that sounds alarming. In practice, it's one of the most well-understood phenomena in cometary science. It's worth pausing on that term specifically, because non-gravitational acceleration sounds far more mysterious than it actually is. It's essentially a bookkeeping category, a label astronomers apply to any leftover motion once gravity's contribution has been fully accounted for. It doesn't imply an unknown force. It just means there's more than gravity acting on the object. And for comets specifically, astronomers have known exactly what that more usually is for well over a century. Comets aren't inert rocks. They're icy bodies that vent gas and dust as sunlight heats their surface, and that venting doesn't happen evenly. It escapes in jets, concentrated streams punching out from specific points on the nucleus, and every one of those jets acts like a tiny, uneven thruster. Push gas out one side hard enough, and the comet gets a small nudge in the opposite direction. Physics working exactly the way a leaking balloon spins unpredictably around a room. That comparison is worth sitting with, because it makes an abstract orbital mechanics concept genuinely intuitive. Anyone who's ever let go of an inflated balloon without tying it off has watched this exact physics play out on a much smaller, much faster scale. The balloon doesn't fly in a straight line. It careens unpredictably, pushed around by wherever the escaping air happens to be venting hardest at any given moment. A comet does the same thing, just over months, instead of seconds, with escaping gas instead of escaping air. That's exactly what multiple research teams tracking 3i Atlas have identified. Observations, including detailed imaging from space telescopes, revealed a system of jets venting from the nucleus in a specific asymmetric pattern. That asymmetry is the entire explanation for the impossible trajectory shift. It's not impossible at all, it's textbook, once you know an active comet is doing exactly what active comets do when they get close enough to the Sun to start venting material. It's genuinely worth understanding how astronomers actually confirm this, because it's a good example of how careful methodical science manages to solve mysteries that sound unsolvable at first glance. Researchers didn't just observe a trajectory shift and stop there. They cross-referenced that shift against detailed imaging of the comet's coma, the cloud of gas and dust surrounding its nucleus, using specialized image processing techniques designed to strip away the bright, symmetric glow and reveal the fainter, asymmetric structure underneath. That processing revealed exactly what the trajectory data predicted it should. A small number of distinct jets, positioned asymmetrically around the nucleus, venting material in a pattern consistent with the direction and magnitude of the observed trajectory shift. In other words, the mystery wasn't solved by assumption. It was solved by directly observing the mechanism responsible, then confirming that mechanism produces exactly the effect measured in the tracking data. That's an important distinction, because a lot of viral science mysteries never actually get resolved with this level of direct evidence. Plenty of unexplained phenomena stay unexplained because nobody can directly observe the mechanism behind them. This isn't one of those cases. Astronomers didn't just theorize that jets might explain the shift. They photographed the jets, measured their asymmetry, and showed that asymmetry lines up with the physics. So why did this become a headline-worthy mystery instead of a shrug-worthy footnote? Because the timing, the size, and a handful of unusual characteristics of 3I Atlas have made it an unusually well-studied object, and a small number of researchers have publicly floated far more dramatic explanations, including the idea that the trajectory shift could hint at artificial propulsion rather than natural outgassing. That theory has drawn enormous attention, precisely because it's the kind of claim that's almost impossible not to click on. It's worth understanding exactly why that theory gained the traction it did, because it's not simply a case of baseless speculation appearing out of nowhere. 3I Atlas genuinely is an unusual object in several respects, larger than the previous two confirmed interstellar visitors, with an unusually active jet system and a chemical composition that includes compounds detected in relatively unusual proportions. Unusual doesn't mean inexplicable, but it does mean there's genuinely more to study here than with a typical, well-understood solar system comet, and that extra complexity leaves more room for competing interpretations. That's actually a healthy part of how science works, even when it produces headlines that oversell the uncertainty involved. Researchers proposing alternative explanations, even unlikely ones, forces the broader scientific community to rule those explanations out rigorously rather than dismissing them casually. The artificial propulsion theory, however unlikely most astronomers consider it, has actually pushed research teams to gather more detailed jet imaging, more precise trajectory modeling, and more thorough composition analysis than a purely natural comet might have received otherwise. Here's the part that actually matters for anyone trying to understand this story honestly instead of just chasing the most dramatic version of it. The overwhelming consensus among the teams directly observing 3I Atlas, using Hubble, using Webb, using ground-based telescopes tracking its coma and tail, is that every observed feature, including the trajectory shift, lines up with known cometary behavior. Gas composition, dust patterns, jet asymmetry, coma brightness, all of it fits the profile of a natural, if unusually large and active interstellar comet. It's worth being specific about what fits the profile actually means here, because it's a stronger statement than it might sound. Scientists aren't simply saying the natural explanation is plausible, they're saying that every independent line of evidence, trajectory, imaging, spectroscopy, gas composition, points toward the same conclusion consistently, across multiple different research teams using different instruments and different analysis methods. That kind of convergence, from independent sources arriving at the same answer through different paths, is about as strong as evidence gets in observational astronomy. That doesn't make this a boring story. It makes it a genuinely fascinating one, just not for the reason the impossible framing implies. What's actually remarkable here isn't that physics broke. It's that we're watching, in real time, a piece of another solar system entirely. Material that formed around a different star, drifting through space for potentially millions or billions of years, behaving exactly the way our own solar system's comets do, light years of separation and all. Think about what that actually implies, because it's easy to skip past this point in favor of the more dramatic framing. This object formed around a star system we've never visited, has never been anywhere near our sun before, and yet the moment it got close enough to warm up, it started venting gas in jets, exactly the way comets that formed in our own solar system do. The physics governing ice sublimation, gas venting, and thrust generation apparently doesn't care which star system a comet originally formed in. That's the twist worth sitting with. The mystery isn't how did it defy physics. The mystery is why does something built from a completely different star system follow the exact same physical rules ours does? And that question is arguably more interesting than any alien technology headline, because the answer says something real about how consistent the laws of physics actually are, everywhere in the galaxy. There's a deeper implication buried in that consistency, one that extends well beyond this single comet. If material formed in a completely different star system, under completely different conditions, still obeys the exact same physical laws we observe locally, that's meaningful evidence for something scientists have long assumed but rarely get to directly test. That physics really is universal, not just locally consistent within our own solar system. 3I Atlas is, in a sense, a natural experiment testing that assumption, and so far, the universe is passing the test. It's also worth talking about what happens next with this object, because the story doesn't end with the trajectory explanation. 3I Atlas is currently heading back out of the solar system, retracing its path outward after its closest approach to the Sun, and it will continue fading from view as it moves farther away. Researchers are using this window, while it's still observable, to gather as much data as possible, because once it crosses back into interstellar space, there's no realistic prospect of ever observing this specific object again. That urgency is part of why this story has generated so much attention within the astronomical community, separate from the public fascination with the trajectory mystery itself. Interstellar objects passing close enough to study in this kind of detail are exceptionally rare. Only 2 others have ever been confirmed, and neither offered anywhere near this level of observational opportunity. Every additional week of data gathered before 3I Atlas fades out of range represents information that may not be available again for years, possibly decades, until the next interstellar visitor happens to pass through. That rarity is worth appreciating on its own terms, independent of any trajectory mystery. Regardless of whether the impossible framing holds up, the underlying reality here is genuinely remarkable. A piece of another star system drifting through the galaxy for an unimaginable stretch of time happened to pass close enough to Earth for us to study it in this kind of detail, using instruments capable of resolving jets, measuring composition, and tracking trajectory to a precision that would have been impossible even a couple of decades ago. Let's talk about what made 3I Atlas stand out from the moment it was discovered, because understanding its backstory makes the trajectory mystery make a lot more sense in context. It was first spotted on July 1st, 2025, by the NASA-funded Atlas Survey Telescope in Chile, a network specifically designed to scan the skies for fast-moving objects that could pose a risk to Earth. What that survey found instead was something far rarer than an asteroid, an object moving on a trajectory so fast, so clearly hyperbolic, that it couldn't possibly be bound to our Sun. That distinction is worth explaining clearly, because it's the entire reason objects like this get classified as interstellar in the first place. Every planet, asteroid, and comet native to our solar system follows an elliptical orbit, looping around the Sun again and again. A hyperbolic trajectory is fundamentally different. It means the object is moving fast enough that the Sun's gravity, no matter how long you wait, will never pull it into orbit. It arrives once, swings past, and leaves forever. That's the signature of a true interstellar visitor, and 3I Atlas displayed it unmistakably from the moment its orbit was calculated. It's only the 3rd object of this kind ever confirmed, following Oumuamua in 2017 and Borisov in 2019. That rarity alone would have made 3I Atlas a major astronomical event. What made it even more significant was its size. Early estimates suggested a nucleus potentially as large as 5 kilometers across, though more refined measurements using Hubble data later narrowed that down to roughly 2.6 kilometers, still making it substantially larger and more massive than Borisov, the previous record holder among confirmed interstellar comets. Size matters enormously here, because a larger nucleus means more surface area, more ice, and ultimately more material available to vent as the comet warms near the Sun. That's directly relevant to the trajectory story because a bigger, more active comet produces stronger, more measurable, non-gravitational acceleration than a smaller, quieter one would. In a strange way, the size that made 3I Atlas such a significant discovery is also part of why its trajectory shift was large enough to actually measure and analyze in this kind of detail. There's also the matter of its chemical composition, which turned out to be one of the more genuinely surprising parts of this entire story. Observations using the James Webb Space Telescope in December 2025 detected methane in the comet's coma, a discovery significant enough to warrant its own dedicated research attention, separate from the trajectory question entirely. Methane detection in a comet from another star system offers a rare, direct sample of the chemistry present in a completely different planetary formation environment, one astronomers have no other way of studying directly. The chemical data matters for the trajectory story too, because different volatile compounds sublimate, meaning convert from ice directly to gas at different temperatures and different rates as a comet approaches the Sun. A comet rich in more volatile compounds, like methane, can produce more dramatic, more variable outgassing than one composed primarily of water ice, which requires significantly more solar heating before it starts venting substantially. That variability in composition helps explain why 3I Atlas's jet system produced a measurable, asymmetric thrust rather than a negligible, evenly distributed one. It's also worth talking about the alignment event that gave astronomers one of their best observational windows on this entire object. On January 22, 2026, 3I Atlas reached an extraordinarily precise alignment with the Sun-Earth axis, with Earth passing almost directly between the Sun and the comet. That kind of near-opposition geometry is exceptionally rare for any comet, let alone an interstellar one, and it gave researchers an unusually clear view of the comet's anti-tail, the fainter secondary structure, pointing back toward the direction the comet arrived from. That alignment window, lasting roughly a week, provided some of the most detailed imaging data used to actually confirm and characterize the jet system responsible for the trajectory shift. Without that specific, temporary geometric coincidence, distinguishing the faint, asymmetric jet structure from the much brighter, more uniform glow of the coma would have been considerably harder, and the trajectory mystery might have taken considerably longer to resolve with this level of confidence. There's a broader pattern worth naming here about how major astronomical mysteries typically get solved, because 3I Atlas is a genuinely good case study in the process. Rarely does a single observation resolve an open question like this cleanly. Instead, resolution usually comes from stacking multiple independent lines of evidence, gathered through different instruments at different times, under different observing conditions, until the combined picture becomes too consistent to reasonably attribute to coincidence. That's exactly what happened here. Trajectory data alone showed a deviation. Imaging data alone showed jet structures. Spectroscopic data alone showed active gas venting consistent with cometary sublimation. No single piece of evidence, taken in isolation, would have definitively resolved the mystery. Taken together, cross-referenced against each other, they produced a picture consistent enough that the scientific consensus settled firmly on the natural explanation, even while acknowledging that some open questions about the comet's precise composition and structure remain. It's worth being honest about those remaining open questions, too, because good science communication doesn't pretend every detail has been perfectly settled just because the core mystery has been resolved. Researchers are still refining exact estimates of the nucleus size, still studying the precise mechanics of how the jet system is distributed around the comet, and still gathering additional spectroscopic data as the comet fades from view. None of those remaining questions challenge the core explanation for the trajectory shift. They're the normal, ongoing refinement that follows any major scientific discovery, the kind of detail work that continues quietly long after the headline-worthy mystery has already been resolved. There's also something worth saying about why claims of artificial origin, however unlikely the scientific consensus considers them, deserve to be taken seriously enough to actually investigate rather than dismissed outright. Science has a poor track record of assuming things are impossible right up until the moment they're proven otherwise, and treating even unlikely hypotheses with genuine rigor is part of what makes the eventual consensus trustworthy. The fact that researchers took the artificial propulsion theory seriously enough to gather additional targeted evidence, rather than dismissing it purely on reputational grounds, is actually part of why the natural explanation carries as much weight as it does now. That's worth remembering the next time a dramatic scientific claim shows up in your feed. The presence of a competing, more sensational theory doesn't automatically mean the mainstream explanation is wrong, or that scientists are covering something up. Sometimes it just means the mainstream explanation had to survive genuine scrutiny before becoming the consensus, and 3I Star Atlas's trajectory mystery is a case where it clearly did. There's a final thought worth leaving you with before we get to the close, because it reframes the whole story in a way that's easy to miss. The fact that this question got asked seriously at all, that a piece of ice and rock from another star system got scrutinized closely enough for the artificial technology hypothesis to even be worth ruling out, is itself a sign of how far observational astronomy has come. A decade ago, an object this small, this distant, moving this fast, would barely have been detectable at all, let alone studied in enough detail to distinguish jet asymmetry from genuine anomaly. The mystery only existed because our tools finally got good enough to notice it. So here's where I land on this. The dramatic version of this story, trajectory shift, unexplained, impossible, gets the clicks. But the accurate version is the one that should actually stick with you. An object that spent unimaginable stretches of time drifting between stars arrived here and behaved exactly like the textbooks predicted, jets and all, proving the universe runs on the same rules out there that it does right here. That's genuinely a more satisfying conclusion than the alternative, if you actually sit with it instead of reflexively wanting the more sensational answer. A universe where physics behaves consistently, predictably, everywhere we've been able to check it, including on objects that formed around stars we'll never visit, is a universe that makes sense in a way that should be reassuring rather than disappointing. Mystery solved doesn't have to mean story over. Sometimes it just means the story gets to be true instead of merely exciting. So here's the question I want to leave you with. Now that we know what's actually driving this shift, does that make 3I Atlas more or less interesting to you? A mystery solved, or a coincidence too clean to feel disappointing? Drop your take in the comments. And if breakdowns like this, separating what's actually confirmed from what's just good clickbait, are what you come here for, hit subscribe, because 3i Atlas still has a long way to travel, and there's more data coming.